The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
So question number 16 is a conceptual one. There's not much to show on the board, so I'm just going to talk it out with you guys. It says, which of the following statements was not a conclusion reached as a result of Rutherford's gold foil experiment? So remember during the gold foil experiment, they shot beta radiation, and they wanted to see how, when it hit the atom, what happened to the rays, how they deflected. So what would typically happen is if the particles in the atom were all spread out like they thought in the plum pudding molecule, the deflections would all be the same. However, when Rutherford's experiment was shown, it showed there was a high center concentration of mass where when it hit, some of these particles deflected at an angle that was greater than 90 degrees. So because there was deflection from the center of this and it wasn't dispersed, Rutherford came to the conclusion that there is something in the middle of the atom, what we now call the nucleus, that consists of more charge. And remember, it's protons and neutrons. So what the Rutherford experiment, the gold foil experiment, showed was that because we have the nucleus, most of the charge for the protons and neutrons is located in the center. Therefore, it is not dispersed throughout the atom. So if we go through and look at the answer choices, it says most of the atom's mass and all of its positive charge are contained in the nucleus. Well, that was a conclusion that was reached. So question number 1 could not be the answer because Rutherford determined, okay, we have the nucleus, and that's because the angle of deflection was greater than 90 degrees. The second says most of the volume of the atom is empty space. Well, that is true. When we're looking at the shell, we have the nucleus in the center full of protons and neutrons, and we have our electrons orbiting whatever element you have. So most of the space around the shell is actually just empty space. So answer number 2 is also a correct assumption based on Rutherford's gold experiment, so that could not be an answer. Question number 3 says, an atom has as many positively charged protons as it does negatively charged electrons. This is true. We learned this when we went over previous questions that, say for strontium, when it was not an ion, it had 38 protons, so therefore it must have 38 electrons. Well, we know that, say, if we have calcium 2+, we don't have as many electrons as we do protons, but that's because it's an ion. So in any typical normal state of an element, protons and electrons are the same number. And the last thing that Rutherford's experiment did was it proved the plum pudding model wrong. That is one of the whole reasons that his paper was published. So that is also a correct answer. So the answer for question 16 is answer choice number 5. All of these statements are correct. So, Rutherford's gold foil experiment proved that there's a nucleus. It proved that most of the atom is empty space. It proved the plum pudding model incorrect, and it also proved that there are just as many protons as there are electrons, or there's just as many electrons as there are protons.